Hi everyone. So today we are going to be talking about solving and creating inequalities. So these are all terms that you should have learned in 7th and 8th grade. But if these are terms that we forgot, vocabulary, we are definitely going to be revisiting that right now. So you should all be on page 21. Okay, so let's just start off with the fact of what is an inequality? So an inequality, that's just a statement that's going to compare two different expressions, okay, that are not strictly equal by using one of the following inequality symbols. You guys need to know all of these, okay? So this first one here is less than. This second one here is less than or equal to. So the way I remember the equals to part is, look, you have the line underneath. Equals to has the line underneath. Okay, our next one, this here is greater than. The next one, again, it has b equals to, and it's facing to the left, so this is greater than or equal to. And then lastly, that line through the equal sign means it's not equals to. Okay, so just continuing on, this is all from our packet. We're on page 21. And let's take a look at this first example here. So you have probably seen at an amusement park something saying along the lines of, you must be at least 48 inches tall to ride this ride. That statement could be written as h blank 48 inches, where h represents the height of the person. Okay, so we want to know what symbol goes here. Is it going to be less than or equal to, greater than, or greater than or equal to? Well, where's the key word here? You must be at least 48 inches to ride this ride. The key word here is at least. At least is always greater than or equal to, right? You need to be at least. So you could be 48 inches tall. You could be 49 inches tall, 50, 51. Hopefully you see my point here. But you could not be 47 inches. You wouldn't make the cut. So this is at least is greater than or equal to. I would write that down. Okay, and I just wrote that here. Okay, let's take a look at a few examples where we want to talk about graphically what these look like if I were to talk about an interval. So I'm just going to put a few numbers. Let's say 4, 3, and then 5 on either side. Okay, so first one, we have x is less than 4. So I'm going to write that. This reads x less than 4. Whoops, I forgot the is. X is less than 4. Okay, so because there's no equals to sign, this means there's going to be an open circle at 4. So when you have less than and greater than, that has an open, okay, open circle. When you have things like greater than or equal to, less than or equal to, that has a closed circle. All right, maybe hopefully this is review. This is a trick that I like to teach my students. If you look at this arrowhead is pointing to the left. So we would shade to the left. Okay? For our next one, we have x is now less than or equal to 4. Well, again, we have the underline here, which means it's closed. So I'm going to put a closed circle on 4. And I'm just going to write x is less than or equal to 4. And again, that arrowhead is drawn going to the left. So I'm going to extend this to the left. And hopefully you guys can figure out how to do 3 and 4, but I'm going to go through them anyways. Okay, so now for question 3, we have x is greater than 4. So because it's greater than, that's greater than, we have the open circle at 4. And now this arrowhead is pointing to the right. So it's pointing to the right. So I'm going to shade to the right. Alrighty. So I'm just going to erase these though, but you should see the point. Okay, and then the last one here, we have x is greater than or equal to. So because it's greater than or equal to, we've got that closed circle, and that arrowhead is pointing again now to the right. Okay, so that's what these look like. And we say x is greater than or equal to 4. All right, let's move on. So we have an example here at the bottom of page 21. We have Nora is planning a birthday party for her little sister Colleen. Nora's budget will allow her to spend no more than $50. No more than $50. Okay, for this party, for the party supplies. 8 children, so we have 8 children, including Colleen, so that's including Colleen, will attend the party. Nora wants to know how much she could spend on party favors for each child. She's also going to spend $10 on a cake. Write an inequality that's going to represent the situation. Okay, well, we're going to let C represent the cost of the party favor for each kid, and we want to write what that's going to look like as an expression. So again, we're spending $10 on a cake, so $10 is getting put down no matter what, and we are spending money on each party favor for the children, for the 8 children. And C represents the cost of the party favor. So if we have 8 children times the cost of the party favor plus the $10 I'm automatically spending no matter what on the cake, that's what our expression will look like so far. Now we want to figure out what inequality symbol can we use to represent this phrase no more than. So if I have no more than $50, does that mean I have $52? No. No more than means, like, another word to say no more than is at most, which means less than or equal to. So if I am less than or equal to 50, so if we want to write this inequality, where here's my expression of 8C plus 10, which is less than or equal to 50, okay? That means I can spend no more than $50 in total combined for the party favors and the cake. Okay? So again, no more than means another word for saying that is at most. I can't spend more than $50. I can spend $50, but I can't spend more than $50. Okay, so that's just another way of interpreting what that means. Alrighty, moving on. Okay, so we should be on page 22 now, and we're going to start to solve inequalities. Inequalities, be careful, guys. These are not equal signs, so don't start doing this. Equals 10, and then start adding, etc. on either side. Keep the symbol. Don't forget to include whatever the symbol is. All right? So I do like to draw my line down the middle. There's nothing wrong with that down the middle of the inequality, but I need to make sure everything looks like this, okay, when I'm writing my steps. Okay. Draw my line down the middle. So first thing I want to do, because we want to get x by itself, well, to get x alone, we want to use the addition property of equality by adding 6 to both sides. So now we have 2x is less than 16. Okay, and we want to get this 2 out of the way, right? Because we want to get x by itself, so get rid of that 2. Well, remember, the opposite of multiplication is division. So we're using the division property of equality. And now I have x is less than 8. If we were to sketch that, okay, so here's 7, 8, 9. Remember, because it's less than, there's no equals to on the bottom. We get an open circle. And this arrowhead is pointing to the left. So we would shade this way. Okay, that's if you wanted to create a sketch. Okay, so let's take a look at question 2. So we just did 1 together. Let's do 2 together. All right, and again, I'm going to draw that line down the inequality symbol. I'm just writing this over here from some space. Okay, so we want to get x by itself. Now, when we're solving inequalities, we always want x on the left. You'll see why. Okay, but we do want x on the left. Keep it on the left. So to get rid of this positive 2, I'm going to use the subtraction property of inequality. So now I have 3x is going to be greater than or equal to. When I combine like terms here, negative 4 minus 2 is negative 6. And I'm going to divide by 3 on both sides using the division property of equality. Because to undo multiplication, we use division. And I'll have x is greater than or equal to negative 2. Again, if you wanted to sketch this, here we have negative 3, negative 2, negative 1. Notice the order. As we go from left to right, these numbers are actually getting bigger as we go, right? So if I want to sketch this, well, it has equals to, so negative 2 will have a closed circle, and this arrowhead is pointing to the right. So we would sketch this way. Alrighty. Okay, moving right along. Let's do question 3 together. So for question 3, we want to start to get x by itself. So, okay, maybe I'll distribute here first. So I have negative 2x. Negative 2 times positive 2 is negative 4, which is greater than or equal to negative 4. Okay, we're trying to get x by itself, so I'm going to draw that line down the inequality. I'm going to use the addition property of equality. Okay, and now I have negative 2x is greater than or equal to 0. Okay, well, we want to get rid of this negative 2 that's out front of x. Remember, there's multiplication here. So to undo multiplication, we use division. And that's it, right? No, some of you guys should be shaking your heads no. Why is this not my answer? I divided by a negative, guys. When you divide by a negative, you flip the inequality symbol. So to flip greater than or equal to, now it's less than or equal to. All right, so when we divide by a negative, make sure you flip the inequality symbol. Okay, so you guys should be able to do question 4 on your own. And in the end, you will get x is greater than or equal to negative 1. So that's your final answer for question 4, but you got to show the work. Remember, we typically want that variable on the left-hand side. It just makes our lives easier. Okay, let's do question 6 together. Okay, so again, we're going to draw that line down the inequality symbol. So let's do that. And I'm going to distribute this negative 8. So let's see, we have negative 8 times positive 1/4 x. Just put that in the calculator, guys. You'll get negative 2x plus, oh, not plus, sorry. And then we have here negative 8 times positive 2, so that's minus 16, and we have the greater than or equal to 40. Okay, we're trying to get x by itself, so I'm going to use the addition property of equality to get rid of this 16. And let's see what we're left with. We have negative 2x is greater than or equal to 56. And would you look at that? What should you see? What should you be picking up on? That negative right out front. So now, when I divide by the negative 2, we flip this inequality symbol. So instead of being greater than or equal to, it's now less than or equal to. So we'll end up with x is less than or equal to negative 28. Okay, so x is less than or equal to negative 28. That's my final answer. And I just want to reiterate here, okay, when you multiply or divide by for an inequality by a negative number, you must remember to flip. Okay, you're flipping the inequality symbol. Okay, and then now just a little brief explanation, guys, as to like why do we do that? What's even the point? Think about the inequality negative 5 is less than 7. That's true. Okay, well, if I divide both sides by negative 1, right, I'm allowed to do that. That's the division property of equality. I now have 5 is less than negative 7. Is that true? No. So this is just an example as to like why we actually flip the inequality symbol. Okay, so I started off with negative 5 is less than 7. That's a true statement. Divided it here by this negative 1, and I was left with this. 5 is less than negative 7, which we said that can't be true, which is why we flip the inequality symbol. Okay, so that's just an explanation as to why, for those of you at home that were wondering. Okay, so moving right along, we have which inequality symbol would you use to represent the following words in words. So these are really important, guys, very important vocabulary words, right? So I'm going to highlight over them. So if I'm describing something that is at most, that is less than or equal to, farther than or greater than, okay, it's another word, greater than. There are a lot of ways that we can represent this. Younger than, think about it as less than. Okay, that's less than. and at least is greater than or equal to. Okay, so you need to know these vocabulary words. Must know what they're associated with. Okay, so moving right along, I want to move over to page 23. So let's start off with some basic terminology for writing inequalities. So let's do the first one together. And how are we going to write this out? We have Max has more than 5 carrots. And our let statement was given to us, so that's nice, where the number of carrots Max has is C. So C is equal to the number of carrots. Okay. So I have Max has more than 5 carrots. Well, we know more than is greater than. He has 5, and we're talking about the number that he has represents C. So we have carrots, which represents C, and he has more than 5 of them. So we have C is greater than 5. Okay. Well, what about the second one? We have twice a number, X. So we're saying let X equal the number, right? So we have twice a number, X, is less than 10. So twice a number, X, is less than 10. And that's it. 2x is less than 10. All I'm just saying is write what the inequality would look like. If we want to solve this now, right, we would use the division property of equality, divide by 2 on both sides. Now I have x is less than 5. No switching of the inequality symbols here or flipping it because we're not dividing by a negative. Okay, so far so good. Let's take a look at question 3 together. So we have Dave has $15 to spend on an $8 book and 2 birthday cards, which he's saying let the birthday cards equal C. So we're saying let C equal birthday cards. Okay. And we want to know how much can he spend on each card if he buys the same number for each friend. Okay. Well, let's read this again one more time over. Dave has $15 to spend. Okay. Now think about that. He has $15. Does he have to spend all of it? No. Can he spend all of it? Yeah, he definitely can. Could he spend $14? He sure could. Could he spend $13? Absolutely. Can he spend $16? No. He only has $15 to spend. So he has at most $15 to spend. I can't spend more than 15. I can spend less than 15. So we can't spend more than. I could spend less than 15. I could also spend 15. So combine these, and that's less than or equal to. Okay? So I know one part of this inequality. I know that this thing is going to be less than or equal to 15. Right? We just established this. Okay, he's definitely buying this $8 book. So the $8 book is happening no matter what. And he's buying 2 birthday cards that cost whatever they do. Right? So we said let them be C. So let's say let C equal, cost of birthday cards. So we have 8 plus the 2 birthday cards. I don't know how much they cost, so let's call it C. And that is our inequality. So now we just have to solve for C. I'm going to bring 8 over to both sides. I'm using the subtraction property of equality. I have 2C is now less than or equal to 7. Using the division property of equality, we're dividing by 2 on both sides. And if you just put that in your calculator, 7 over 2 is the same thing as $3.50. So he can spend $3.50 per card. Could he spend more than that? No. Could he spend less than this number? Absolutely. He could have spent $3 a card. He could have spent $2 a card. He could not spend, for example, $3.60. Nope, that wouldn't work. Okay. All right, so still being on page 23, I'm going to do 5 with you guys, and you guys are going to do 7. So my first step for question 5, I'm going to draw my line down the inequality symbol, remembering we have less than or equal to here. Okay. And I'm going to get rid of this 3 first. I'm going to use the subtraction property of equality and bring that 3 over. So now I have 1/2 times 3 minus x is less than or equal to 17. All right, just using some basic mental math here. Okay, 20 minus 3 is 17. Great. What do we want to do next? We have a few options. We could either distribute the 1/2, or we could multiply by the reciprocal. Because what's the reciprocal of 1 over 2? 2 over 1. So if I multiply that side by 2 over 1 and this side by 2 over 1, these cancel. Okay, so I just used the multiplicative inverse. So we just applied the multiplicative inverse. And now I have 3 minus x is less than or equal to, well, 17 times 2 over 1 is 34. We're almost there. Okay. We want to get x by itself, so to undo the addition right here, right, there's that invisible plus sign, we're going to subtract 3. So now I have negative x is less than or equal to 31. Remember, there's really a negative 1 out front here. So I'm going to divide by negative 1 on both sides. And now, when I divide, so let me just write it again here. When I divide by a negative on both sides, we flip the inequality symbol. And there's my final answer. Okay, we'll start you guys off with question 7, again, because it does require us to use the calculator. Okay, so first thing that we want to do is we're going to want to distribute first, right? Draw my line down the inequality symbol. We want to distribute, and I'm going to show you guys how to use the calculator on this in a second. Let's clear out what's in there. Okay, well, I'm going to distribute by multiplying this 5/3 times 6. So I'm going to go into my calculator. I've got alpha, I want to make sure you can see this, alpha, y equals, enter. And I'm going to type in that 5, move it down over 3, move to the right, and we're multiplying it by 6. You are not writing 6x. You are not writing 6x in the home screen. That makes no sense. X only goes in the y equals screen, only in this screen. You will never write x in the home screen. Never. Okay, so we just distributed that, and we got 5/3 times 6 is 10. So I'm going to rewrite this, though, as 10. Don't forget the x. Okay, and let's do the next piece now. So I have 5/3 times 3. So again, in the calculator, alpha, y equals, enter. There's my fraction. I'm going to type 5, move this down, 3, move to the right, and we're multiplying it by 3, enter. And there you have it. 5/3 times 3 is 5. So I'm going to write here plus 5. All right. And now we're just going to start to simplify. And you guys can do the rest. I'm just going to tell you what the final answer is, because this is a problem I want you to do on your own. But your final answer ends up being x is less than or equal to negative 1.5, or x is less than or equal to negative 3 over 2. These both are the same answer. One is written as a fraction, the other one is a decimal. Okay, let's keep going. Let's do question 8 together. Hopefully you guys are seeing how important solving these inequalities are. Okay, so first thing I want to do, let's draw our line down the inequality. I'm going to simplify on the left-hand side first. So we're going to simplify on the left-hand side, and then we'll simplify on the right-hand side. So I see that I can distribute here. I have 6x minus 2x minus 4 is greater than, and now let's distribute on the right-hand side. I have 2 minus 3x minus 9, right? Okay, let's see. Can we simplify anything on the left-hand side? We sure can. I've got 6x minus 2x, so that leaves me with 4x. And on the right-hand side, what can we simplify? I have 2 and negative 9. 2 minus 9 is negative 7. And now we want to start to get x by itself. So I'm going to add my 3x to both sides. I'm using the addition property of equality. And now I have 7x minus 4 is greater than negative 7. We're almost there. I'm going to add 4 to both sides using the addition property of equality. And now I have 7x is greater than negative 3. Again, guys, I just combined like terms here. Negative 7 plus 4 is negative 3. And we want to get rid of this 7 out front. Remember, it's being multiplied by x. You don't have that. You're not going to ever see the multiplication symbol. You guys just have to know that that 7x is being multiplied. So to undo multiplication, we use division. So I'm using the division property of equality. And I'm left with x is greater than negative 3 over 7. Notice there was no flipping going on here. We did not divide by a negative. Okay, I just divided by a positive 7. Does not matter that this was negative over here. We did not divide by a negative here. So that's my final answer. Awesome. Okay, let's keep going. Let's take a look at question 10. So for question 10, we want to solve the inequality and then graph its solution set. And we're going to state the largest integral value for which a can be. Guys, this word here, integral, that just means the integers. So like integers are like ... negative 3, negative 2, negative 1, 0, 1, 2, 3, and so forth. Those are your integers. Okay? So let's start by getting a by itself. I'm going to add 5a to both sides. We like the variable on the left when we're solving inequalities. So now I have 7a minus 4 is less than 17. And I'm going to use the addition property of equality by adding 4 to both sides. And I have 7a is less than 21. We're going to divide by 7 on both sides because to undo multiplication, we use division. So I'm using the division property of equality here. And I'm left with a is less than 3. So on our number line here, let's put some numbers here. We've got negative 1, 0, 1, 2, 3, 4. I'm just putting some numbers here. Okay, you can put as many as you want, but put at least 3 on here. Okay, so a is less than 3. Well, we have an open circle at 3, and now this arrowhead here is pointing to the left. So I'm going to shade to the left. Now, we're not done. The question says, what's the largest integral value for a? What is the largest value that a can be? Can a equal 3? Well, no, we said a has to be less than 3. So what is the next number after 3? 2. So 2 is the largest integral value in the solution set. Okay, we're going to do another one together, but 3 is not in the solution set. That is wrong if you write that. Okay, let's do another one. Let's do question 11. Question 11 now says, what is the smallest integral value for x? So find that smallest integer in the inequality on the solution set. Well, okay. Let's first start by distributing our fraction here. Okay, so you guys should use your calculators. 3 over 5 times 45 is 27. And now we're multiplying 3 over 5 times negative 10. So again, guys, just putting this in my calculator. And I end up getting negative 6x. Because remember, x does not go in the home screen. We'll even write that. X never type in the home screen on calc. Okay. Oop, I wrote typer. Never type. Okay. And we have this is less than 36. We want to start to get x by itself, so I'm going to subtract that 27 on both sides using the subtraction property of equality. And 36 minus 27 is 9. And I have negative 6x is less than 9. Divide by negative 6 on both sides. And when you look at that, I'm dividing by a negative, guys. So when I divide by a negative, whoop, flip the inequality symbol. So we're no longer less than, we're now greater than. And in the calculator, I want to reduce this 9 over negative 6. So I want to reduce this. So if I come over to my calculator here, turn it on, okay, clear out anything in there. I'm going to just type alpha y equals enter. I've got 9 over negative 6. Negative button is down here. Negative 6. Enter, and look, it just simplified it for me. So it actually reduces to negative 3/2. So let's write, we have x is now greater than negative 3 over 2. Which if I wanted to write that as a decimal, that is x is greater than negative 1.5. Okay, so now we want to put this on a number line. So let's see, we've got 0, I've got 1, I've got 2. The reason why I'm skipping each space is to allow for those halves, right? Because we have this negative 1.5. I have negative 1, negative 2, so this negative 1.5 is here. Negative 1.5 is there. Okay, and we want x to be greater than. X has to be greater than this negative 1.5. So it's greater than, so it has an open circle here. The arrowhead shifts us to the right. And I want to know what is the smallest integral value for x here. So what is the smallest integral value that x can be? Well, x cannot equal this negative 1/2. It can't. It has to be greater than it. So the next integral number that I hit is negative 1. So we're going to say negative 1 is the smallest integral value in the solution set. All right, and there you have it. Okay, we're just going to do 2 more together. So let's take a look at question 12. Word problems are really important, guys. We have Tony can carry up to 18 pounds in her backpack. Oh, that's a lot of weight. Okay, so we can carry up to 18 pounds in a backpack. Her lunch weighs 1 pound, and her gym clothes weigh 2 pounds. So let's write that down. And we also have each of her books weighs 3 pounds, and we're using B as our variable. So her books weigh 3 pounds each. Okay, so another way of writing this, if we have 3 pounds each and we're representing the books as B, that's 3B. We want to know how many books she can carry in her backpack. So we said we can carry up to 18 pounds. So can I carry 19 pounds? How about 20 pounds? Why not? It says up to. I can carry up to. That means no more than this amount. I can carry 18 pounds. That's good. I could carry 17 if I wanted, 16, etc. I couldn't carry 20, and I couldn't carry 19. Not even 18 and a half. It's too much. All right, so let's write out our inequality. Okay, so we have her lunch weighs a pound. She's got her lunch on her. She's got her gym clothes. That weighs 2 pounds. She's got B number of books that weigh 3 pounds each. And I'm going to carry up to, so no more than, 18 pounds. And that's my inequality. And you guys can finish this one. Just solve for B. Well, you end up finding, in the end, B is going to be less than or equal to 5. That's your final answer. All right, one more problem I'm going to do with you. One more problem. I'm going to do 13 with you, and you're going to do 14. Okay. So for question 13, we're given these 2 functions, right? They're written in function notation. So here's my f of x. Here's my g of x. And we want to know for what values of x is f of x greater than g of x. So let's write it out. We have 3x minus 2 is greater than, here's g of x, 4 times 10 minus x. Okay, so let's start to solve for x. I'm going to get my variable on the left-hand side, but I first notice on the right-hand side here that I can distribute. So let's distribute this. We have 4 times 10, which is 40. 4 times x is 4x, but there's subtraction in the middle. And we're just going to continue to simplify here. Okay, so like I said before, we want to get x on the left-hand side. So using the addition property of equality, I'm adding 4x to both sides. We have 3 plus 4 is 7. We keep the x. Minus 2, I'm just rewriting. And we're going to get x by itself, so we're still getting there. We need to undo the subtraction here by using addition. And now I have 7x is greater than 42. And my last step, to undo multiplication, we use division. We're not dividing by any negatives here, so no flipping of the symbols. And we'll have x is greater than 6. Okay, now that I solve for x has to be greater than 6. Well, it might help to draw a number line again. So let's do 5, 6, 7, 8, maybe 4. Now, x is greater than 6. So again, notice that this is an open circle at 6. And where does my arrowhead point? Let's see, my arrowhead is pointing to the right. So I'm going to shade this way. The question says, what is the smallest integral value for which f of x is greater than g of x? So on this interval, what is the smallest value that's in that solution set? And remember integral values, like we said, like -2, -1, 0, 1, 2, ... Okay, on either side. Well, 6 is not in the solution set. We have an open circle there. So the next smallest number is 7. Okay, I want you guys to do question 14, and I'm just going to write what the final answer is. So make sure you have this written down for 13. You're going to do 14. Okay, those are the final answers, but you guys need to provide the work to get there. Alrighty, hopefully we found this video helpful. We'll talk soon.